Okay, let us move seamlessly. Yes, thank you for that presentation. It's a great video. And let's move seamlessly to Q&A. Is there an expert in the house who wants to take questions? I used to think when I was a grad student, I used to think there were experts. You could go to people, they would know, and you could ask them and you get wise answers. And after a few years, people start referring to you as an expert, and you think, oh dear, there are no experts. There are only people who have done it a few times and kind of worked a bit. And yeah, so everybody's an expert here. Maybe everybody's got questions, and the answers are probably in the room somewhere, but not necessarily at the front of the room. Okay, we kicked off, and there was a question quite early on, which I could boil down to as, where are we going with all this stuff? And let me just hazard my guess at an answer and see if it has any resonance. In the processing space, which is where our bit of Oxford Instruments lives, I see two drivers. One is productivity. People want whatever it is they're doing, particularly if it's getting closer to industrial application, they want to do it faster and more reproducibly. The other is precision. And very often that's on thinner and thinner layers and smaller samples. So I think you've got two axes there. One is just go faster and maintain adequate controls. And the other is up the precision all the way, because certainly when you get to single atomic layers, which is, well, you've seen talks this afternoon where we're there or thereabouts. We're working at the atomic scale, so we need far more precision. Does anybody care to amplify on that? Where do you see things going? What's driving your next programs?
There's a third one that I see, which is, I would call it robustness. You know, particularly in multi-user environment, you know, how dependent is it what the instrument's doing on, you know, I want to grow this film, right? And all of a sudden I decide that I'm going to want to grow it on a different film underneath it. Is it going to grow the same way? Is the stress of the interface the same? Right? Robustness towards what the previous user of the instrument was doing with it. Like, do I need to do 3 hours of paper conditioning and maybe it will come back to my recipe that I developed over 2 years ago on the same instrument?
Yeah, I'm with you.
Kind of demand
Oh, that one is a hardy annual. To convert it to gardening terms, it just keeps sprouting up every year. So yes, I think that's. I mean, there are some best-known methods which more or less say clean it or condition it or do both. When all else fails, open it and give it a good scrub. But I mean, that's not bad as a baseline. I mean, that's the sort of apple pie and motherhood approach that actually gets you 90% of the way. And yet, I mean, at least once in today, I've heard somebody say, oh yeah, but my etch rate shifted by, oh, I don't know, 20%. I was sitting there quietly dying, thinking, oh God, 20%, that's a lot. What would do that? And yes, that one is worth looking at.
Your question is quite right, because the thinner we go, the more sensitive we probably will get to the robustness of change of conditioning and things that have to change. It's not full, it's not a micron, it's not a 2 microns, and you can lose right in the interface a little bit. You get down to atomic layers. So,
and it was like, that atomic layer deposition, what is it? Depends on what you're depositing it on.
yeah, it does very much depends on what you're positive on. It's a very key parameter.
I mean, I guess maybe building upon Vladimir's question. I mean, one of the things that's extremely frustrating for any user of a facility like the one we have here at Caltech, where you have many different clients doing many different things, is the robustness, your process robustness, even when you don't have full control over it 24/7. So are there better diagnostic tools that can tell us my chamber, my setup is in, in a state which is as near to identical as it was when I, used it last? Seems to me that a lot of the time you go and use a tool, and the, this robustness issue has a lot to do with the history and the current state. So I don't know. For me, there's just a lack of diagnostic tools on a lot of these instruments.
Could you explain that OES for this? It goes along with the ALE, more accurate monitoring things in the chamber.
Right.
It's a really good, easy way to measure the condition of the chamber.
Right.
How long would you be prepared to spend checking your chamber was good?
Well, I can tell you, I mean,
as a routine thing.
at least in research, and I can only speak for some of the people in my group, but it's probably 90% of the time. So let's say we use the tool, 10% of the time is for doing our actual process, 90% is setting up.
Okay,
so
anything we can
that's the opposite of what you'll have in industry maybe, but in research it's all about, well, do it better. I mean, we spend so much time trying to prep the chamber, making sure we have everything right. If we can do that better, it's not even time, yes, but I think just finding more accurate and more sophisticated, potentially, methods. But OES, that sounds like something that I remember when I was a graduate student, I just hooked up a multimode fiber and then ran it into one of these like little miniature spectrometers. And I don't know if it's anything beyond that, but that's what I did, and it was okay. I didn't know what I was looking at particularly. Yeah, right. So I think it's mining that and knowing what to look for is probably half the battle. But to me, that's like, at least in a research environment, really vital. And even when it comes to, so measuring bias voltages on your table, okay? I'm not sure this is the right way to do it, but we scratch our table. I think it's an alumina-coated table, and so we scratch it so we can get a reliable, bias measurement when we're etching. But that's not really the way I'd like to do it. I'd like to have a much more accurate estimate of, and that'll change over time as it gets coated. So I don't know. I feel like improved diagnostics could be really important in a research environment. So especially, as you mentioned, as we go to more sensitive, we're more particular with what we're etching and what we're stopping our etch on.
It's very good feedback, because we obviously go through ideas and thoughts about how we can improve the tool with the bottom tools. So yeah, it's a very good thought to take away.
I don't know if that is what you were talking about, Vladimir, but I mean, robustness to me, that's part of the issue.
And then if there were, more diagnostic things that were built into the tool, so that as you're doing it, red lights coming, this may be getting out of spec, or something that sort of happens in the background, so all the time, right? I mean, there's a fair bit of that sort of already there, right? Are there more things in the measure?
Yeah.
There is some free information there which we could mine.
Yeah.
But some information is not free because we don't have to add diagnostics to it. So if I put a value, is it 1% of the full value, or 5 or 10% of the full value?
But I think it's a value proposition to you to actually say we can have 5% of the cost, but save you over a year 10%. Therefore, you see the value.
I mean, yeah, there's a chicken and egg issue, just that nobody in the industry really does this. And I mean, Oxford Instruments, I've always felt, really does develop technology. You know, they don't just go and copy and then, you know, mass market. So, and also you serve the research community probably better than a lot of the other similar, maybe larger tools. And I think the research community really values that. At least I know I do, having those, you know, abilities. And so we can do that ourselves. We can add it on, and we can try to do some software development and try to, you know, that's certainly possible. But I would imagine it's not a 5% proposition. It's more like a 20% proposition for value. Yeah, yeah, but that's what I think the number is around there. Like, I think they're, you know, different people, you know, might feel differently, but I think in a research environment, universities especially, but also national labs, they would, that are doing research, they're going to want to pay for these diagnostics. I don't know. Do you think that I'm wrong? Yeah.
It's more the time of the people in the user center spending, you know, trying to understand what went wrong with something that used to work.
Right.
If that time can be saved, I mean, it's worth money.
Yeah. A lot. Yeah.
And I would just support that from UCLA representing the CNSI and engineering teams that having real-time information about what's going on, given the realities of hundreds of users running many, many different processes over long periods of time, having that information available is worth value proposition.
Yeah, I will put it straight back to the community to drive it, because if it's not in the spec of the tool, and many tools are on a tender, if it's not in there, and we offer it but there's a cost, the bottom line usually is a very, very strong driver for purchase, and the cheaper tool will come through. And your own rules will force you to buy that tool. So specify the thing you want and drive the behavior. I mean, as you name the requirement, I'm thinking how to do it. And 6 more people in the room have probably got ideas already about ways to do this. It drives a program of work for us. It drives a program to say, it's not just put a diagnostic on, this will save you time. We've got to show that. We've got to generate the data that says, with this diagnostic, we could get you back to this knife edge process could operate faster compared to not using it. And that's months of work on our side to generate that raw data. It's worth doing, but you could help drive that by specifying it as a desirable feature, that there was a reproducible means of knowing chamber was back to use of 2 or 3 core processes within 3 hours when you use a locking up or something like that.
Part of our issue is we don't know what type of diagnostics is possible.
Right.
Well, don't worry about that. I mean, we've got a reasonably good idea of what the sources of variability are in our own tools. I mean, we've got 20 of our own tools at home in the team, so we have got some horsepower to bear on that. If anybody has particular insights, we're not going to say, "Oh, go away." We'll listen.
Yeah, but I think that you could even do, like, I'm thinking, I don't know, thinking about it from a marketing standpoint, if I was in your shoes, I'd want to get a niche, and so I'd want to say, okay, I represent to this community somebody that can provide diagnostics, right? And so you got to find something that you're going to be able to provide that's not going to be, like you said, okay, huge amounts of 6 months of work. But let's say we start with accurate DC bias monitoring. You know, even if that's trivial, it doesn't matter. The point is you get to market that, okay, we are able to provide diagnostics real time to, you know, improve your setup time or reduce your setup time, improve your robustness of your process. And then eventually you start, you know, customers going, oh, can you do this? Can you do that? And eventually you build up your repertoire. But it seems to me that would be the way that I would approach it. I just think there's nobody else there that's going and talking to places saying, we can do advanced diagnostics, or we're willing to do advanced diagnostics and work with you. Because eventually then I would write in I'd write in my quote, you know, I want to be able to do this, 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 and this. And you know, if Oxford Instruments is the only company that can fulfill that, then, you know, that's a winning bid for you. So I just think that, like Vladimir said, I also don't know all that's available. It's part of, you know, because I'm ignorant, part because I haven't listened to previous talks. But I do think it's an opportunity, for sure, especially in the types of environment, and eventually could be quite important. If it's proven to be very useful, then you could imagine, then you can start putting in more resources, right? So you got to prove it, and then, but it's costly to develop any one of these diagnostics things to make it work and to make it, you know, functional if you're going to build it in. So yeah, I understand that.
We make one, we've already got it.
Yeah, and I would start with something simple and just advertise it.
I mean, part of it is like, you know, you do service calls, right? You know probably
Yeah.
better than anyone else what goes wrong, right? Those things that get the largest impact on your users in terms of going wrong, you know, can they be monitored better so that when they start to go south?
I know we can. I've been writing the spec for our software team repeatedly at 3-year intervals for 15 years because the information is in the tool,
Yeah.
but for some reason they're busy. Like, who sends the set point to the mass flow? We do it. Who reads the readback from the mass flow? We do. Who has an accurate clock knowing exactly what happened? We do. So we know the settling time of the mass flow.
And probably users like,
There are countless examples through the tool where the command of the response and the time is known, and all we've got to do is draw that information out and present it in a good way. And a wealth of tool status related information is there. I think very little of that has to do with reproducible processing. I think it has to do with knowing something's going wrong.
Yeah, but it doesn't have to be reproducibility. That's also part of the issue. Yeah. I have to say, so we just recently did this X20 upgrade, and the software is a lot better. So even though I know you've been saying it, I'm pretty impressed with the updates to the software, at least for our tool. So we just did this X20 upgrade, and I can tell you, I wish I'd done it 3 years ago. So it's not cheap, but it's...
I'm writing this down, you're getting quoted.
Okay. I mean, it's night and day. So on my tools, the tool we had, it's, you know, this ICPRE and PECVD, we got it 15 years ago. Mechanically, it's great, but the software upgrade was a big deal.
Yeah.
And so anyway, I think that improvements along those lines, they don't have to cost a lot, but they could make a big difference in selling. I had a bunch of different ideas we could talk about, and I don't want to use everyone's time here, but one thing that I thought was really interesting that was mentioned in some of the early talks, and I would like to get other people's thoughts on this, was this idea of going to smaller tools. So you mentioned this, I can't remember what the model number was, but it was a small plasma tool.
Yeah,
So how far can one take that concept? Is it possible to make like benchtop systems that, you know, for pieces? Because a lot, again, the research community cares not so much about wafer processes, but also pieces.
I'll pass this back to you, because if you're tendering for a tool, very often, I think the thought process is, well, what's the largest thing I ever want to put in this tool? Will it be an 8-inch wafer? When would that happen? Once in 10 years. I need something to do an 8-inch wafer. Therefore, you buy an 8-inch.
That's what happens. Yes,
tool.
I agree.
And again, it's up to the buying community to grow up a little and say, actually, we don't need that. What we need is a 2-inch tool or a 3-inch tool or a 4-inch tool, and challenge the equipment provider to say, we need some floor space. Is it cost or is it floor space that drives your question?
I would say it's three things. Potentially floor space. Cost is certainly one. And I think maintenance. Like you have these huge tools, and they, they have these, I mean, I don't pay the electricity cost, thankfully, for running my lab. Well, I do through overhead. But, I mean, I am not using the throughput of this thing. It's enormous. The pumps that are on it, it's totally way out of whack with the scale of what I'm doing. So I think that, yes, cost, floor space, even just the cost of ownership, it feels to me that going to a smaller tool set for at least most research, almost I would say 99% of the research environments is would be valued. Now, some shared facilities will have to have a tool that can do bigger wafers, and that's fine. You can get a tool for that, but
so I'm going to run on Dutch auction with everybody here. I want you to put up your hands if you process coupons or larger. You process coupons or larger.
what does that mean?
Coupon is square centimeters, say. Okay. And
Coupons are larger, yes.
Now do you do 2-inch or larger? Okay, that was actually more hands going up, no hands went down. 3-inch or larger? 4-inch? 6-inch? We start to lose it. Okay, so it seemed to me that around about 100 millimeter tool will capture 80% of the market, but not.
But not Vladimir.
But
Yeah.
not a coupon tool.
Yeah.
Well, you could think you're making a really micro, but actually, most people want to actually put something that's reasonably physical in there at some point.
Well, I don't know, Guy, you should answer. For our facility, how many people are etching wafers at a time?
Maybe a few percent.
Few percent. There you go.
We'll etch a 6-inch wafer.
We'll etch a wafer at a time. If,
But let's see, if we did a 4-inch tool, the benchtop,
yeah.
would that fit most of your requirement? I suppose the question that you're asking in around.
Yeah, how large do you need to go, and then
How large
what's
do
the
you
break?
need to go?
I think 4 inches probably.
How small do we need to go?
Yeah, I mean, again, it's a matter of, I'm not sure it's ever been tested, but most people will, what they'll do is they'll say what Mike was saying, which is, well, maybe one time in the next 10 years I might need an 8-inch wafer, and so therefore I buy a 8-inch system. And then, I don't know, every time we've done that, Guy, I can go back and look, and we've never used an 8-inch wafer through the process, basically, every time we choose a tool this way. It's like the stupidest thing ever. So I don't know if we can break that habit on the customer side. It's a good point. But to me, it's an interesting idea. And the other thing that would be, the reason I think it's interesting is you could possibly integrate different tools together if they were smaller. And that could be interesting. And I'm sure that that's a thing that you've looked at, and it may not make...
Moving from chamber to chamber or multi-processing chamber?
Chamber to chamber. I mean, if you have to have big vacuum runs between things, it's hugely expensive. But if you can imagine, if you could really make smaller etch and deposition chambers, like really a lot smaller, I don't know whether it's physically possible, whether the physics make sense.
It's all key to the size of the thing you're processing. Yeah. What you've got now is pretty much what we think you need to do in a 200 millimeter substrate. It would be an interesting challenge to take it back home and say, go and do the same job, but you've only got half the floor space.
I'm thinking like a fifth of the floor space, but okay.
Okay, really radical.
No, I'm thinking really radical, and then you could do so. I mean, I'm really radical. So this would again be a whole new set of customers, I believe. People would buy it for a very different reason. They'd say, "Oh, I'm going to use this just for pieces." They wouldn't even think wafers. And if you had that, you wouldn't even sell it to people to do wafers. You'd just sell it to people to do pieces. But I can tell you, almost every research, lab is going to want to do, have a tool that just does pieces, guaranteed.
Mike, here's a question for you. As you go smaller in size, the chamber, you're changing the surface area to volume ratio. Is that going to affect the processing at all? You're going to have more wall effects, you're going to have more outgassing from the walls, you're going to have more gathering from the walls.
There's challenges. Yes. You certainly have to look at those scales. You're right. Babies lose heat faster than adults.
Yeah. I think it's just interesting whether the physics really radically changes, and whether you could still do it. Yeah.
I think it's the same challenge we've got now. Different scale.
But I mean, just a very small tool that could be laid on your tabletop, and you could go from station to station.
If it's a small tool, it needs basic jobs that everybody needs doing, it probably isn't going to do the really refined jobs, which need the sophistication of a
Really?
high-end tool.
I don't agree.
Okay.
I mean, I can tell you all of the processes we do are on a one approximately coupon size,
Yeah.
and they're just as complicated as what you do on the wafer scale. It's just that we don't want to go through a whole wafer because we don't need it. We're not making, and so I think that when we're testing out processes, that's the point. We'll dice up our wafers and we can get, whatever, 100 pieces out of a wafer. That's worth it.
We do the same.
If you envision yourself building a small tool, as he says, would it cost less? Or would it just cost the same as a 4-inch tool? Are you saving the space, or are you saving money?
It's about that. You've got to look at the component count as much as anything. Some things you pay for the amount of stuff, but actually most of the chamber hardware is component count. If it's a specially shaped shard in this big or one this big, it's still in the same order. There is a saving if you can save on pumps. If I could really scale down on pumps, those are expensive. RF generators are expensive.
Yeah.
Vacuum valves, if you go down to size. I don't know how to go down to size in mass flows.
No, that's fine. You can you would offload, right? Gas pod, that's fine. I don't need to change the gas pod. I just need the.
It's a good question.
So presuming the research community can come together and have some consensus to present to you prior to Oxford, right? For Oxford, what is the mechanism to do that? Every company has a different culture, right? You're saying that you've been telling software for 15 years that you want this upgrade. How does the research community?
It's just because I'm pathetically inadequate.
Well, but how do we get your attention, right? Because any one person can have limited access.
Can I say you have got our attention?
There is a resonance. We have an internal question in our mind about this end of the market.
This end of the market.
We have an active program on it.
This is incredibly good VOC for us, actually.
The reason I brought this up actually is not so one of the applications I foresee goes back to diagnostic. So I don't know, every once in a while I have these dreams that we could do some of these things, but what if one could actually do high resolution imaging while you're etching or depositing? So the chambers are so big, it'd be hard to build a nice imaging system to get, micron scale resolution. But if you start to make them smaller, one can actually resolve what's going on, and put some filters in to get rid of the emission that's coming from, let's say, your plasma. But, you could potentially be imaging what's going on the surface. It's some sort of a very advanced endpoint detection is the way to think about it. But I think those sorts of things could start to become viable.
I think more in-situ monitoring is coming. I don't see how you deliver the precision end of what my roadmap says is happening without going to in-situ. Some of the imaging is troublesome to put in. I mean, can you put a ramen into a high-temperature CDE? No, it will probably melt. And in order to get uniform processing, we actually want to minimum furniture and intrusion. And a lot of the imaging techniques actually need close up.
Right, exactly.
And now you're in the way. I mean, even to the extent we had some people who say, I want to get an in-situ look with a laser interferometer on my drawing or my etching film. And I said, we can do that, but I can tell you the etch rays is different where you have that window over there compared to elsewhere because you spoiled the uniform RF boundary.
Yeah, no, I mean, I want to look through I want to see the whole wafer. That's my point. I want to image the whole wafer. But it would, I don't think it scales to large chambers. It would be a very hard optical problem to solve. But maybe as you shrink your chambers, it becomes more realistic. Yeah.
Saturation and some capture going on. Let me go back to multi-process in one chamber and let's just float an idea. We showed you ICD-CDE and showed you that possibility that if we said this is an etch tool and it's a depth tool, does that get you somewhere? Or no, you really need to separate it out for X, Y reason, which I can't foresee.
I can tell you, I mean, I bought a clustered PECVD ICPRE tool. Okay, so with a thought that I could go back and forth. Now, if you could do it in one chamber, that's great. But in the end, we ended up not using that. You know, we always would break vacuum and go and look at things in between etch and depth. So it wasn't, I mean, not that we're not doing it every once in a while. It hasn't been something that we do all the time. Of course, if we could buy one chamber for a similar price that could do, you know, or some savings and it could do both, that would, I mean, seems to me would be a good selling point.
My mind comes back to the fact that, though, how do we precondition and do that? That's something we would have to, you know,
No, we'd have to work
we'd have to work on that because.
But the hardware has converged. ICP-CVD and ICP-Etch is remarkably similar in hardware.
Mm-hmm.
So I was just wondering if it would be preferable to offer that as well, if we could get that up together.
What about?
We have to show the swap. Here's the reproducible PECVD, and here's the reproducible etch, same chamber.
What about ALD? Can you add ALD in that? Or is that something that where you have to redo all the MFCs and everything?
No, ALD is different. We did the first ALD tool that we made for somebody. We thought, yeah, let's just adapt to PECVD, and we adapted PECVD, and it was a tool from hell.
Yeah, that's what I remember.
I never wanted to do that again. It was horrible.
I worked in the competition then, and I'm glad they didn't know.
Yeah, I was the guy who won the award.
Yeah.
It was a learning experience.
So remember it well.
No, there are some things you can't that you can't combine very easily. But there is a convergence at this level. Okay, you had another question too.
Is there any others for the audience? Yeah, I have a few more, but we also don't want to run too long. Yes, Vladimir.
Small chambers and such, right? Is that at some point start to exclude people who do a lot of stepper work? Because steppers lithography may not work on smaller regular pieces as well. Right, so that's why I was kind of hesitant.
No, I think Oscar's point. We get wafers from customers, and we break them into bits to do some processing on them. And I think that's what you're basically saying.
Yeah.
You clean into smaller bits. So the night for a
If
stepper.
I have an 11 mask process,
Huh?
if I have an 11 mask process,
Yeah, then I think you get to shoot one die, right? That's not so great. So you would want a different tool. I don't think this replaces every, wafer scale tool. Yeah.
give you some boundary conditions.
Yeah.
But it does produce a gap in the market. Do patterning on a die. If I could pattern a die,
Don't you do everything with E-beam anyway?
that'd be great.
Not everything.
We do everything with E-beam when we probably should be doing it with a stepper, but we just don't want to make masks. We're that lazy. So I thought you were too.
Well, a lot of our things are large, so E-beam is just lots of E-beam.
Yeah, you need to do. Yeah, yeah. Okay. I had one other technical question that I didn't hear talked about, but I know is utilized in the research community, and that is with plasma etching. And that is this idea of putting angled Faraday cages or Faraday cages of different geometries above your sample, and thereby, turning directing the plasma, and you can etch it at various angles when you do that. So, is that something that Oxford's looked at all?
We've had a couple of customers who do it. I think it's a little bit desperate to do
Oh yeah,
it.
they're very desperate.
I think it could work over small length scales up to about a centimeter.
Yeah, that's about right. These are tiny little centimeter scale.
If you're thinking about doing it over a wafer, I would direct you to an iron beam, an iron mill
Yeah, yeah.
with tilted.
Like a chemically assisted ion beam etch. Yeah, that's what. So.
It does like an ion beam.
Yeah, that's what I built when I was a graduate student. But I've seen it more and more in ICPRE and people in the research community. Like you mentioned, somebody mentioned diamond and quantum. So that's what they do. That's how they make some of the best devices. And again, they're doing it on millimeter-sized devices, so not even coupon. These are micro coupon. What's that? These are yeah, they're only a few millimeters size.
Talk about that one down. I mean, there's enough demonstrations out there that the proof of concept.
Yeah, it works. It works.
So,
it's just making it easier to,
so
I don't know,
can
integrate with the tool.
Can we work that up into a little offering?
Yeah, I think it's something where you could imagine like some little, even if it's something you sell that allows you to put it on your robotic arm for when you transfer your carrier wafer in. That would be like a really nice thing because you've got to go through the slit valve. You want to make sure it clears and everything, right? And these Faraday cages are tiny. So they can do that, but whenever you put them in, you're always a little worried. So even just making some little adapter that allowed you to, or thinking about the geometry and even saying, yes, it works on our tools would be something to think about.
What I love about this community is as soon as a problem is posed, you yourself then start to work on the problem and solve it. we have an irresistible drive to say, oh, I want to do this better. Oh, let's do it this way. And
right. Not always the best way. We don't solve it the best way. We solve it, though.
Let me ask one now. What's the feature you most value in your tools? Not necessarily an Oxford tool. What's the thing you think, that's a must-have, and people don't even know what it is?
Not great.
Robustness, yeah. I mean, I read here, if your car had an uptime of 98%, you would change it.
Yeah.
How's the tool and quoted uptime of 95% is the real one?
I can tell you what the technicians will tell you, which is make them easier to work on.
From a front-end point of view? Or
No. From preventive maintenance and mechanical point of view. I mean, we talk about floor space all the time, and yes, it's valuable. But, I mean, some of these tools, not necessarily, I'm not saying your tool is any way, but the whole industry, I mean, these things are just beastly to work on. It sounds great to make this thing really small, and then,
There's a screw from hell, but nobody could possibly...
Well, no, honestly, like, I'm not joking, and this is for Oxford tools. I have several specific tool sets, which I've actually had to cut, like, crescent wrenches or whatever, so that I can fit in and do various, things on the tool, because otherwise there's no humanly possible way you can fix something. So I have a whole Oxford tool set, from back in the day, which I still use. So I don't know. I think being able to, this robustness question came up, uptime came up, but being able to service the tools and really thinking about that, how do we take this thing apart? How do we more rapidly allow for changing out or doing things like that? That's like a huge differentiator in my opinion. When I work with a company that does that has really thought that out well, so that there's both their tech support can come in and fix things really quickly and easily, it makes a big difference. And I think that when we talk about tools being down, part of the reason is that they're impossible to debug or they're